Hello and welcome. Welcome to STEM at Home with Newton's Road for 6th and 9th graders. We are so glad you're able to come today, and this is your chance to learn from some experts in our region and each other as we continue to learn at home. My name is Barb Termott. I'm the Executive Director of Newton's Road, and we are a regional nonprofit supporting STEM learning and career exploration. Our special guest today is Annalisa Wiesner. She is a mechanical engineering student at Michigan Tech and our Newton's Road intern. She's a TC native and a high school recipient of the Newton's Road Scholarship to the Engineering Summer Camp at Michigan Tech University. And now she is just 7 credits away, which is like a half a semester from getting her mechanical engineering degree from Michigan Tech, while she's working with us in the meanwhile until fall semester. And we're so excited that she can share with you today about engineering. What is engineering? You can say hi, Annalisa.
Thanks, Barb. Hi, everybody. I'm excited to be here today.
So this session is going to be recorded and available on our Newton's Road Facebook Live site and YouTube. Matt's going to share a few things about Zoom, although,
Hey Barb, it actually looks like there aren't any Zoom attendees right now, but if anyone watching on Facebook Live joins the Zoom later, if you want to ask a question, there is a Q&A button at the bottom of the screen in the Zoom interface if you're on a computer. There's also a chat button if that works better for you, and there's a hand raise button. If you click on the participants button, it will show you a hand raise button in the bottom right hand corner, and then you could indicate that you'd like to ask a question, and we'll unmute you and allow you to pose your question to either Barb or Annalisa. If you're on Facebook Live, we'll do our best to answer any questions that you pose in the comments there. But that's about it for participating on Zoom. Back to you, Barb.
Thank you, Matt. So now we're going to take a quick peek at our who's Newton's Road. And so come over here. So this is our Newton's Road website. And we have many different shows going on right now with the community media. And you can get all the information about any of those shows by clicking the alert on our homepage and find out all of the dial-in information. There are 4 shows a week currently. Also on our homepage, in addition to a video about who we are, if you go down a little ways, you see a mailing list. And we ask that if you'd like to learn about more of the things that we're doing, that you join this mailing list and get our monthly newsletter and other key updates, usually just 1 or 2 communications a month. We also now have a STEM calendar that has STEM events that are happening around the region. Right now, they're all virtual, but in the future, they can be at any location that we will post them. You can see some things here from Tattle. We've had some from the Challenge Island and the Children's Museum, etc. And you can choose to see the things that are just live, like this one that you're on right now, or you can choose to view an any-day science activity that if you just need something to do that day, you've finished your homework or whatever, and there's a fun thing for you to consider doing. So I think that's all we're going to share right now, and we are going to go right back to Annalisa. Back to you, Annalisa, all about engineering.
Thanks, Barb. Hi, everybody. Hi, 6th through 9th grade friends and whoever else happens to be watching today. I got to tell you, I'm really excited to be sharing with you. And as I was preparing for this presentation, I was just reminded of all the possibilities and opportunities that are in engineering, even things that I'd never known before I learned preparing for this presentation. So I'm excited that you're here. And yeah, so what is engineering? I like to think of engineering as solving problems and thinking critically. And engineering is so broad. You'll see as we go through the presentation today how broad engineering is. It's hard to capture what is engineering, but what all engineering disciplines have in common is that engineers solve problems and think critically in order to solve the problems. So I remember being in the car with my cousin a couple years ago, and we're the same age. So we had both just started college pretty recently, and we don't get to see each other very often. So we were kind of catching up and asking, how's your degree going? And I remember saying, what I really love about engineering is how creative I get to be. And he said, creative? When you say engineer, I don't think creative. And it's true. I think there's really a misconception that engineering is only for people who want to work on computers a lot, people who like to make cars or fix cars, or people who want to design and build roads and bridges and trains. And not that creativity doesn't go into those jobs, because it totally can. And great opportunities exist in engineering for all those people, if that's your thing. And if your thing is something else, great opportunities probably exist in engineering for you too. So I just want to talk to that a little bit and open your minds to the possibilities and opportunities in engineering that you may not consider first when you hear the word engineer. Let's go to the next slide. So like I said, engineering is very broad. These are just some of the types of engineering, but they're the most common. So we have computer engineering, electrical engineering, aerospace, chemical, civil, mechanical, industrial, biomedical, software, manufacturing engineering. So remember, engineering is thinking critically and solving problems. So if you're a computer engineer, you're going to be using critical thinking and computer skills to solve computer problems. And if you're a mechanical engineer, you're going to be using critical thinking and mechanical skills to solve mechanical problems, right? So you can see that many fields of engineering are interdisciplinary, meaning you might just not use computer skills. You might also use electrical skills or manufacturing skills. So when you go into engineering, although you may focus on one discipline, meaning you get a degree in one type of engineering, like me, I'm getting a degree in mechanical engineering, but you're going to know about a lot of the different types of engineering and have the skills to work in many of them if you choose to. And they all know how to do two things: think critically and solve problems. Okay, next slide. So what are the possibilities? They really are limitless. Down on the left, on the right bottom, we have environmental engineering, wind power and solar power. If you like sustainability, you like keeping the earth clean, environmental engineering might be a great option for you. Mechanical and electrical engineers are going to be working on that power drill. Even makeup needs engineers and has engineers behind it. That would be chemical engineering. Next slide. A water pump is an awesome example of mechanical engineering. And I was just watching a short YouTube video yesterday wondering, how does a water pump work? And it uses a piston cylinder with a couple valves to work. It's very simple. And if you don't know what those words mean, maybe you don't know what piston and cylinder and valves are, you learn all those things in school, so that's okay. It doesn't mean you won't be a good engineer. You learn that in school, and you can. We have all been created with such intelligent minds, so just follow what you're interested in and whatever piques your curiosity and explore that. Okay, I cannot be the only one that loves chacos. There is an engineer behind that design and how they use one strap. I love that. Diapers, too. They have to be engineered to be comfortable and to hold what they have to hold, and engineering for that too. Okay, next slide. Okay, I love the idea of a treehouse engineer. So you can see the civil engineering that goes into a treehouse, all those supports underneath the treehouse, and a civil engineer has to do the analysis and determine, can the tree support the treehouse, right? And then what if it snows? Will the treehouse cave? A civil engineer has to make sure that it's safe. This young man also was applying mechanical engineering principles by creating an elevator with his bike. I just think that is so cool. If you look this guy up on the internet, if you just search bicycle elevator treehouse, you'll see all about this guy, and you'll see too he created another treehouse that actually rotates around the tree when you turn a wheel. It's so cool. Okay, next slide. Okay, we have rockets, we have the International Space Station, that is aerospace engineering. We have biomedical engineering up in the upper right. If you think back to our diagram, biomedical engineering is going to be a discipline that encompasses both mechanical engineering and biomedical. Did I say biomedical first? I meant biomechanical. Okay, next slide. We have a bridge. There's an engineer, a civil engineer behind the bridge building, making sure that they're structurally sound and aesthetic. I mean, bridges are normally very pretty to look at too. That's a good skill to have as an engineer. A park, that is plastics engineering. How fun would it be to build something for kids to play on? Okay, and we have computer engineering on the bottom. Does anybody know what that is? That's a fiber optic cable, which is a relatively new technology that actually uses light to bring you very fast internet and communications. I think I said computer engineering. I think that would actually be more like electrical engineering, and a branch off of that would be optics engineering. Very cool. And in fact, I think we actually have fiber optic cabling in Traverse City now. I went to a meeting a couple years ago about, they were trying to bring it to Traverse City, and I think by this time we probably have it. Okay, next slide. I love the salad spinner. That has mechanical engineering written all over it. You can see I really geek out about the mechanical engineering examples. If you've never thought about it, the lid of a salad spinner has a bunch of gears in it, and that gear system is what makes the basket spin quickly when you can put very little effort into turning the handle. So that's another very simple example of mechanical engineering. We have the Amazon drone, computer engineering. Engineer was behind the computer mouse, and cookies. Yes, cookies. Even engineers work on cookies. Food engineers, right? And they find ways to preserve food. They make sure that, you know, the cookie is going to stick together and not crumble apart. Next slide.
And even design the machine that makes the cookies.
Yes. Good point. Did you know You could be a fashion engineer and design clothes that are functional. Maybe you design sports clothes, maybe not. Maybe you design clothes that are functional and aesthetic. A food engineer, like we just talked about. An artificial intelligence engineer, you can engineer the workforce of the future. Ocean engineer, music engineer, also called acoustics engineer or sound engineer. A packaging engineer, if you've always been fascinated with the way that things are packaged. A robotics engineer, a regenerative engineer, which actually has to do with medicine. This is one of the ones that I learned recently in preparing for this presentation. And that means that if your tissues are damaged or they're injured because of some injury, how can you solve that problem? Next slide, please. Okay, what do you study in engineering school? If you do go into engineering, you will study a lot of math and science and technology. So that is definitely something to consider. Calculus, physics, chemistry. I did not actually know that I liked science until I started studying physics in college, in engineering school, but I found that I loved it. Statics is the study of things that aren't supposed to move, that are supposed to be static, like houses and bridges. Engineers use drawings to communicate what they've designed and how to build it. And so that's what engineering graphics will teach you, how to create and how to read those drawings. Materials class is how do different materials behave under certain stresses, for example. So say you bend a paper clip, which is made of galvanized steel, it's going to behave differently than if you bend a piece of plastic or a piece of wood. And then what if you heat it up? What if you heat up the steel? What if you heat up the plastic? What if you heat up the wood? What will happen, right? That's materials. Circuits is what is used to make electronics. Thermodynamics is the study of heat and energy. If you've ever heard energy cannot be created or destroyed, you are on your way to knowing thermodynamics because that's the first law of thermodynamics. And programming is computer programming. There are endless possibilities of classes you can take in engineering school. These are just some more. Vehicle dynamics is one that I took. Wind energy is one that I wanted to take, but didn't get a chance to. Human-centered design, I think, is really cool, especially if you are concerned about helping people. You want your job to make a difference and help people. People are always going to have problems. And what do engineers do? They solve problems using critical thinking. And so if human-centered design is learning what do people need, what exactly do they need, and how can I help people by solving their problems, okay? And, you know, too, I'm going to mention it's okay if you don't love each of these classes or if the classes don't necessarily sound interesting to you. Like I said, I didn't know that I liked science until I went into engineering and I learned it, until I experienced it a little bit, right? And some of these I still don't especially love. I don't especially love programming. I didn't love the class, but now that I know it, I realize that it's very useful, a useful skill to have, especially in today's world. So, and I still find engineering fascinating, even though I don't love every class that I took in engineering, right? Next question, or next slide, please. So who is engineering for? Engineering is for anyone who wants to or is willing to. Like I mentioned, you don't have to love every part of it, but you do want to be interested, of course. Learn a systematic approach to solving problems. Again, we have solving problems. Study math and science. Yes, lots and lots of math and science in engineering. Apply mathematical equations to model the real world. Do you know there's an equation for basically everything in the universe? There's equations to tell us all about gravity and how planets stay in orbit, how cars crash. There's equations to tell us how quickly a pipe will lose water if there's a hole of a certain size, right? Equations tell us everything. And in engineering school, you get to learn how to apply those equations to the real world. Pretty cool. If you want to and like to understand how anything works, make things functional, help people. Next slide, please. Okay, local pathways to engineering. So I'm first going to talk about some things that you can do right now. If any of these things that I've mentioned or that you've heard about engineering pique your interest at all, you can do some really easy things to learn more, right? You don't have to make a big commitment to go to engineering school to find out if engineering is right for you. So some ideas are to take some classes in math, science, engineering, and technology. And that can be perhaps while you're still in middle school, that can be in high school. And notice, do you like algebra? Do you like geometry? Do you like calculus? Do you like physics? Do you like chemistry or biology? You can join a STEM club. I know there's robotics teams at several of the schools in the area. You can talk to a local engineer or even just an engineering teacher at your school. You can, when you're older, you can take Intro to Engineering at NMC as a junior or senior in high school. You can consider dual enrolling through your high school. You can consider early college. I was in early college and I did take Intro to Engineering as a senior in high school, I believe, or maybe a junior. You can consider getting a summer internship or going to a summer camp. Sometimes there's scholarships to allow you to go to a summer camp. I got a scholarship from Newton's Road for a summer camp when I was in high school. And a really easy thing is to just watch videos about engineering and learn a little bit more. Like I said, as I was preparing for this presentation, I got so excited and just learned much more about engineering than I even knew was possible. So it's pretty fun to just do some exploration. Okay, when you're in high school, search out and see, are there engineering classes at my high school? I didn't know that there were engineering classes at my high school. I went to West Senior High until I was a senior. And I did take a couple of them as a senior. But not just engineering classes, you can also take maybe some AP math and science classes, or just if you just want to explore, just commit, say I'm going to take one class and see what I think. There's a Simatech program at some of the local schools. I believe it's at both Central and West. I'm not sure about any other schools, but that will get you into learning more science and math and technology. And I know they even have an internship portion where you do get to go out and work as an intern. MTA, if you don't know what the Manufacturing Technology Academy is, you can watch the episode from last Thursday where Tim Wheatley, who's a teacher at MTA, talks about the program. But that's a program where you get to go and learn all about STEM for half your day in high school. And the Career Tech Center also has a drafting and design program. And if you remember when I talked about engineering graphics, learning about reading drawings and making engineering drawings, that is what you can learn from the drafting and design program at the Career Tech Center. And that's something that I also did in high school. And then college, guys, I really recommend going to NMC or at least checking out the programs that are at NMC. I can't think of a reason not to go to NMC, but of course you can go straight to a university. NMC does have some agreements with all the following schools that I've listed down there. Michigan Tech is a really popular one where you can go to NMC for 2 years and then transfer to Michigan Tech for your other 2 years. But there's agreements with all these colleges. There's also an engineering technology program at NMC, which is a 2-year degree instead of a 4-year degree that you would get if you went to, for example, Michigan Tech. And engineering technology degree is going to give you a very specialized training and will prepare you for very high demand jobs in this area. So in fact, Jason Slade from NMC Engineering Technology is going to be on the show on Thursday at the same time, 4:30. So feel free to check that out on Thursday. Next slide, please. Why be an engineer? Since you're good at a lot of things. And I can confidently say that you are good at a lot of things because we all have enough talents and passions and interests to have rewarding careers in various jobs. But here are just some things to consider about engineering that you may not get with other jobs. So engineering is very flexible. You can easily change between careers or between industries because, like we talked about before, so many things are interdisciplinary, and when you have a base education in engineering, you can have a mechanical engineering degree, but do industrial engineering or do electrical engineering, right? Engineering jobs pay well and are generally stable. And lastly, everywhere in the world will always need engineers. And you can even travel and be an engineer. Next slide.
So I have a question that's come in. Do engineers have to work on the computer all day?
Engineers can work on the computer all day. And if it's not your thing to work on the computer all day, you don't have to. In fact, I'm a firm believer in creating your own career. And yeah, if you don't want to work on the computer all day, you certainly don't have to. In fact, I'll tell you my latest career idea, which is treehouse engineer. I think it'd be so much fun. I already showed you the picture, but to be a treehouse engineer. And yes, there's going to be a little bit of computer work because I'm going to be designing probably on a CAD program, but I'm also going to be out in nature a lot.
And there's another question here. Is there anything you wish you would have done differently with school?
Yes, I wish I would have gone to MTA as a junior and senior in high school. I really think very highly of that program. And I did go to NMC for 2 years. I'm really glad that I did do that for my education, and I love Michigan Tech. And if anybody wants to talk about my experience at NMC or what it's like at Michigan Tech or any of that, please feel free to reach out to me, and I would love to just brainstorm with you about what might work for you and what might fit you well. But to answer the question, I wish I would have gone to MTA, but overall, I'm pretty happy with how I did the education piece.
Well, great. I don't see any other questions at the moment. So I guess you have a moment to wrap up and summarize for everyone about being an engineer.
Thanks. Well, I guess I'll just say that engineering is not a scary thing. When I was in middle school and high school, I kind of wondered if it was scary to go into engineering, and it's not. It's a way to access and to use your creative mind. And all of us are creative. I'm reading a book right now called Creative Confidence, and I love how it describes that all of us have that creative mind that we haven't necessarily tapped into recently, but we have it. It's very natural. And so I encourage you to use your creativity and practice using your creativity. And again, feel free to reach out to me if you have any questions or want to talk some more.
Thank you, Annalisa. And I was very interesting, and I learned something too. And so I want to also take a moment to thank our sponsors and supporters who make this show possible that are listed here. And I want to mention our upcoming live shows, so you can see what's
Hey,
coming
Barb.
up. Yes.
Sorry for the interruption, but I stopped your screen sharing, so you'll have to reinitiate that.
Ah, okay.
Sorry for the clunkiness, viewers at home.
No worries. So here are the upcoming live shows. We have STEM at Home for K through 5th on.
You're still not sharing your screen. I'm sorry.
Now I think I'm sharing my screen, right?
Yep, we see it.
Oh, great. Okay. So here are our upcoming live on Thursday. We have K-5th at 2 o'clock, and we have 10th through 12th. That's when Jason Slade was going to talk about the engineering technologies that was just mentioned. And we will have seeds come during the K through 5th. And we have the parent coffee break next week, Tuesday. And the 6th through 9th will be again on Tuesday afternoon at 4:30. We hope you join us. And I think I will just take a moment to again thank our sponsors and our supporters and all of you for joining us today. Hope to see you next time.